Welcome, everyone.
Good morning. Welcome. Nice to see you, John.
Thanks.
Delighted that you all can be here. Thanks for being at our third Haystack Connect conference. Thanks to all of our sponsors, and thanks to Intel for being the community sponsor. Again, we thank everybody for being here. So at the end of the day, why are we here? It's because of one word, data. The importance of data. It's transforming everything. Data has changed the way companies in every industry does business, manages performance, and is now considered an irreplaceable asset. When it comes to Haystack, we are now well into a very active adoption and acceptance phase, thanks to all of you, and we appreciate that. We want things to have what we've learned and the work we have done to open and make this all available to streamline the use of data. The work of the Project Haystack organization is simply for all of us to use data in a better and useful way. So as you saw in the video, this year's theme of the conference is Making Data Real. And we believe you'll see this and experience this through all the content that we're going to deliver, from today's keynote speakers to the various breakout sessions that are ahead of you for this day. So again, thank you. And John, you want to say a few words?
Yeah, sure. Thanks. Thanks a lot, Mark. Welcome, everybody. And again, I want to extend our thanks for all of you taking your time and resources to be with us. I want to again thank the sponsors, because that's why we can have the good time that we seem to be having here already, because of the their contribution. I try to oftentimes explain this event to people, and it's actually kind of challenging. It's not related to one manufacturer. You can argue it's not even related to one technology, because Haystack can be used across, Haystack principles and concepts can be used across so many different vendors and protocols, et cetera. And then why do people come together? What's the general theme? And the general theme is to unlock the future of better, and then fill in the blanks. Better buildings, better energy, smarter systems, the Internet of Things, all of these things together. But what's unique about the event is that it's all volunteer driven, right? Those of you who participate in the forums to make the technology advance, those of you who come to these events, it really is a really unique environment. And this year, about 60% of you are returning attendees, and that means 40% of the attendees are new, absolutely new to our event, and often that means they're very new to Haystack and what we're trying to accomplish here to make data work together well. One of the other things that's interesting to mention here is that there are a lot of viewpoints, right? You're going to see presentations here by other open source initiatives, other standards efforts, but the common theme we all share here is we need to make these systems work together better, more efficiently, lower cost, to deliver better results to owners and operators. So it makes it a pretty unique group here. Some of the first-time sponsors I mentioned last night, that are just amazed at the quality of the attendees, right? At this event, virtually everybody gets it, right? Everybody is involved in delivering these types of systems. So again, we thank you with that. A few, just notes about the past. We run this event every 2 years. Seems to go by pretty quick. Too quick. But it's been 2 years, and the progress both in the organization and in the standards effort, building out the Haystack technology even further with more libraries. We've got sessions on that today. But you'll also see how much the community has evolved in how they're using these technologies, from initial ideas to being built into a wide range of products, both hardware and software products, and being used across all different types of applications. I'm sure you're all here specifically to take part in the technical sessions, but I think you're going to see some amazing presentations and learn a lot from that. So we had some big events this year. We were very proud and honored that Intel joined Project Haystack. They joined at the board level to help us direct the organization and the future work, and became the community champion sponsor for this event. but we also have a lot of other members who've joined, associate members who've joined. It's pretty easy to be an associate member. People ask me, what do you get for joining as an associate member? And that's basically, you get to help the organization do these things and move forward. So we appreciate all of the people who became associate members. And the final thing will be, and I think you'll see in a number of sessions, this event is also a call to action, right? There is no secret team of people who are individually solving all of these problems. The new libraries get built, the new features get added because of audience participation. So this is definitely an audience participation sport. So you're going to hear the call to action in numerous areas. There's so many areas to participate, so many things to do to bridge Haystack with other data standards out there, to work with other standards organizations, to bring it into other domains. Lighting is a growing domain, security, et cetera. So with that, we're going to move on and introduce, Mark will introduce our first keynote speaker. But again, thank you for being here. We greatly appreciate your support.
So I truly am honored to introduce our first keynote speaker today, Rita Wouhaybi. She's a system architect from Intel, and she's with the systems architect and the Industrial Energy Solutions Division in the Internet of Things group within Intel. Her professional career includes more than 15 years of industry experience in engineering, management, and research. Her areas of expertise include peer-to-peer, distributed networks, one of my favorite, even though I don't understand it, game theory, the use of machine learning and networking, and social networks. And this is a truly amazing piece of information on Rita. She has filed over 150 patents and published over 20 papers in the acclaimed IEEE and ACM conferences and journals. She's also been a recipient of several awards, both academic and industry achievements. Rita received her PhD in electrical engineering from Columbia University in 2006. She holds a BE and ME degree in computer and communications engineering from the American University of Beirut. Please give a warm welcome and join me in welcoming Rita Wouhaybi. Thank you.
Good morning, thank you. Wow, it's bright in here. I want to start with a complaint, not that that's what I usually do, but really, who designs those? 5 feet people do exist, come on. So needless to say, I'm not gonna stand in there today, and you guys should all forgive me for it. It's a great honor for me to be here. I'm really excited about being part of this vibrant community. I have been a fan of Haystack for a while now since I learned about it, and I want to give credit to that to Milan, who's going to come here afterwards and talk about his go through his talk. I have been at Intel for almost 11 years. I spent the first 10 years of my career as part of Intel Labs, which is the research arm that Intel has. And it was really exciting. And after a while, I realized that all these 10 years, I've been through multiple projects. They all involved one form or another of data. Health data, wellness data, let's optimize data routing, let's come up with new algorithm, let's see how we can expose data, APIs. So it all involved data. And my background is in distributed networking, and it made sense to move into the Internet of Things group and start being more involved in this technology that is exploding and becoming more important to a lot of industries, including Intel. So today, I want to talk a little bit about something that Milan had mentioned, I believe, last time he was here, and some findings about Haystack that a professor that we're working with have looked at. I though want to use that as a launching pad and then talk about how we can use Haystack in other domains and some areas to watch for, because I believe Haystack have been ahead of the curve, ahead of the game. And one of the cool things about it is how simple it is. And I think its elegance is in its simplicity. So we want to make sure that, the next page, as we're turning it over, that we are ahead of that game, and we're making sure as a community that we continue to be out there and thinking about where the future of data is going to bring us. So for those of you who were here, I apologize if Milan have already talked about that. But this work is not ours. This is a work that came out of UC Berkeley. And there is a professor there called David Culler. Professor Culler have done a lot of work over, 30, 40 years now in many areas, including databases and data and storage and optimization. So he became very interested in smart buildings. And in 2015, he had one of his grad students look at data and smart buildings. And they took a very cool, very academic exercise, but it also was an empirical exercise. And they said, there are a lot of standards out there. There are a lot of organizations. There is a lot of ways that we can describe data for a smart building. Which one of these standards or ways of describing data for smart buildings does better than the rest? And for doing so, they kind of looked at the applications that already exist today. They identified 89 applications. They said, OK, let's look at these applications and see what they are doing. And they were able to categorize these 89 applications into eight different buckets based on what kind of use case they are supporting. And then they also wanted to describe the relationship because, I could have an application that talks about or that answers energy efficiency and another one, but they are doing it in very different way. There are relationship of how the data is exposed. So they said, OK, if we look at all the players, users versus entity versus thing versus sensor, what have you, there are 5 different graphs that can capture all these applications. So they wanted to take all these 89 applications, take the data standards that are out there, and do a mapping. Say, OK, application number 1, standard number 1, how well can I, if I were to use you as my data language, how well would you let me define what I have? And they looked at 3 vectors. They looked at how complete each standard is, or each way of describing data models. Can I expose? Can I describe all the relationship? And is it flexible? Here is their scorecard that they came up with. Okay? So they came up with this scorecard. And by the way, after they started by saying we have 8 different categories of applications, they realized that really there are 5. There are few use cases that once you start looking at them, even though they look like they are different, you can bind them together. So they came up with this scorecard in here. And in the scorecard, you can see that in a lot of places, Haystack does actually really well. Okay? It aced it. Now, they're academics. They're a little thrifty. You remember how hard it was to get an A or an A+ in a class. But overall, they did not take into consideration that something like Haystack could be expanded easily. So some of the low numbers, like the 57 and the 50%, I wouldn't worry about that much. The one, though, that struck me as interesting is the last one, is the 42%, occupancy modeling. And I had a chat with Professor Culler, as well as looking at the paper. By the way, if you have some time and you would like to look at the paper, it's a good read. It's not one of those reads that you start it before bedtime and it helps you fall asleep. It's actually a really good read. So the 42% might be raising a flag that once we get into areas where we need to do a lot of data analytics, that sometimes data models might be getting in the way. And that aligns with another finding that his group has looked at, which is that some data models, because of the way they are structured, and because when we start thinking about the use cases in creating the data models, we're not thinking about the deep learning, we're not thinking about the big data kind of use cases, we might be getting in the way. Because when you start querying those data storage and databases, it might be that the data model does not match with what you are querying, and you end up needing a lot of queries to get the data set that you want to. We don't think about things like correlation when we are creating our data models. So the point in here is Forbes defined what a data scientist, the life of a data scientist looks like, and they have done some empirical data. Sorry, oops. So they have done some empirical collection of data in here of a data scientist, and it turns out that a data scientist spends a lot of time either collecting or cleaning data. You don't really want them to spend this time. You're paying too much for them to sit here. You really would like them to sit here in the green area. You want them to sit in mining of patterns and creating and refining their algorithms. While in reality, they hang out a lot of times just collecting and cleaning data. And the last thing we want to do is to add to this. We don't want to make the bottom of the pyramid fatter. We want to make it as lean as possible. So we really should be thinking about how we should get out of the way, not be in their way. I was really fascinated by this, and I started talking to multiple teams inside of Intel and outside of Intel and academics about what is so hard about creating metadata or data models. And I heard one or more of the three things that I have on the left-hand side. The first one, they talked about too hard to develop. And in here, really, they weren't talking that much about Haystack. I think Haystack aces that one. But as you know, there are some organization standards out there where I print their manual or I'll download the PDF, and we're talking about a 400-pager in order to get started. And then you get your data modeling person, and he or she spend a long time in order to create the data model. By that time, the development team, even if they are part of their agile process, they're getting itchy. They're like, come on already. We need to start running in here. So this is one of the things that people complain about that I think Haystack actually did an amazing job. The second one is the poorly defined. And again, this is probably the #1 problem that Haystack solves. But sometimes it comes back because the data modeling person took so long that when the development team started running, they discovered that something was missing. And instead of going back and talking to the data modeling person, they start creating hacks. And the hacks will look something really ugly. The third one is the analytics incompatible. And I heard that come back fairly recently from multiple teams talking about, well, when we designed the data model, we weren't thinking that we're going to run this linear regression thing on it, so on the data. So now in order to get the data that I want to analyze, it is taking me quite a bit of hassling and moving, this stream from here and that stream and align them and then take whatever and then query back and make sure they belong to the same building and so on. So we want to make sure that, again, we're not standing in the way. Now, you all know that at Intel, we're like the optimization geeks, right? We love optimization. As a matter of fact, optimization is part of our DNA. This is what Moore's Law is about. You give us something, we shrink it and put more in it. And then you give us something else, we shrink it some more and put something more on it. So I have a little fascination, which shouldn't come as a surprise, in optimization. And the second piece of the puzzle is how fast we can access the data, because this is a big important piece for analytics. So here is another piece of work that came also out of the same team in UC Berkeley. And what these guys were looking at, because that team looks at databases, was how would they create a time series database that is very, very fast. In fact, their time series database that I'm going to tell you about in here beats Cassandra, which today holds the throne in terms of reads and writes as a time series. So what they have done in here, this is, again, a piece of work that came out of David Culler's team, and the student who's working on this, his name is Michael Anderson. He created BTRDB, Berkeley Tree Database. It's not a very catchy name, but it does a really good job. So what he does with this database is, as we know, trees are very efficient. So if you send me time series data, that's what he's doing in here. If you send time series data, he takes that data and saves it in a tree and then attaches it to the rest of his data. So he ends up, you grab the root, it's in the middle, everything starts from here and then rolls down into the second side. So that's the gist of it. And it struck me as another case of elegance and simplicity. It's not rocket science to create a tree. but he created some efficiency in how you would write it, how would you do batch writing into it. But what was really cool about it was not the fact that he created a tree. B trees have existed for a long time. What he came up with, he said, you know, for time series database, we're data junkies. We're collecting all this data. What's really interesting about what you do with the data. And to a large extent, we're doing a lot of statistical functions, computations on the data. So what he did, he said, I'm going to take every root in every branch on my tree, and I'm going to compute a set of statistical functions, a set of statistical functions and save them there. And every time you do any update on that root, on that branch, I will recompute them, and they will be there ready for you. I will cache them for you. That does only work if the functions are associative in nature, right? If you have something nonlinear and complex that is sitting in the root, that will not help you because you'll need to recompute it if you're looking at it for a wider part of the tree. But if you're looking at things like average, minimum, min, max, count, then those would work. And then if you have any piece of analytics that needs to run on a subset of your data, you can take this cache computation that's happening there and just use it. And that is a simple idea, but it works, and it's really neat. And it helped him in a lot of times in running some analytics achieve 100x performance gain over something like Cassandra. So what does that tell us? If we want to get out of the data flow, we want data to be as fast as possible. We don't want to get in the way. We should continue to optimize in storage, in databases. We should make sure that whatever we're capturing our metadata, whatever we're putting our data models in, is compatible to the flow. And we should be able to think about those use cases that are not visualizations, that are not simple optimizations, that can get into areas where maybe you'll be using things like deep learning or heavy correlation or any kind of regression, and then be able to support that at the end. And we can achieve that by improving along the way the databases, having high-performance hardware, but also keeping in mind when we're designing our data models where we're going. Right now, I would like to switch gears a little bit and follow a line of thought that I had some time ago. Smart buildings are really interesting. And I remember when I joined the Internet of Things group at Intel, my manager said, oh, go help with smart buildings. And I was fascinated by this team because it's kind of sits in the middle of a lot of other markets. And it has similarities to a lot of other places as well. If we think about it, my slide was supposed to look a little bit prettier than this. I apologize. If you think about it, smart buildings have some commonalities with cities, right? Some of the privacy concerns are there. They're similar. There are some other characteristics that both have in common. It also has some commonalities with smart grid. Optimization of power is one of them. So it is similar to smart grid in other areas. And it has some similarities to home, except that it is a more professional version of home. However, some of the consumer use cases are quite similar between smart buildings at home. The difference between home and smart buildings is that, home I can walk into Best Buy and buy myself a few cameras or, have somebody install some security stuff. And it's more ad hoc. It's more, it could be a hacker style kind of home improvement project that I can take on in a weekend, while smart buildings is a professional version. It actually reminds me of the difference of when I was in grad school and I went and bought a bunch of hardware pieces and stitched them together, and I called it a computer. And now I have my Intel laptop. On the outside, they look the same, right? They're both computers, they're both running Windows. But gosh, my Intel laptop is way more reliable because there is someone in IT making sure that it's running, that my data is backed up, that I have high reliability, that viruses don't get into my machine, and so on and so forth. And the last one is more of the one that I have the highest interest in, which is factories. So kind of reliability and availability, the requirements in smart buildings and factories tend to get similar there. They have a similar flavor. So that got me thinking, what if we can port some of this knowledge and transfer some of this knowledge that this community have, that you guys have acquired over the last few years, and transfer it into a different domain? And John kind of hinted to that in his intro, expanding into different domains. And that is an opportunity for all of us to seize, because if we look at the number that IDC has in terms of market size, as time goes on, factories and manufacturing is a big one, right? We are looking at almost doubling between 2014 and 2018. This is an opportunity for all of us to seize and to think about. Yes, of course, things will need to change. Maybe way more metadata need to be created. More things need to be defined. But at the end of the day, if we can keep that simplicity that made Project Haystack also useful, then that's a win-win for everybody. Also, I would like to think that if we expand into different domains, if this community becomes a larger community that has interest in other areas, then really all the parts are going to be way more than the summation of the pieces. And then definitely some of this could be done with alignment to other organizations. And I think, as I'm sure Milan will talk about, is that we are well positioned in this community as a great place for interoperability. So basically, the way I see the future with such a powerful yet simple and elegant data model proposed by Haystack is, first of all, the connect gear, the expand gear, and the analyze gear. So the connect gear, this is happening. Data is flowing. The expand gear, these are some domains that we can start thinking about as a community and bringing to the table and discussing. And the last one is supporting analytics, because really this is where the future is going. We have started seeing it in other markets, flying by, and we don't want to be, that rock that ended up being in the way. We want to be ahead of the game. We want to understand how analytics are going to hit on data models and how we could support them. And last but not least, I want to leave here with a great saying from one of our founders, Robert Noyce. Don't be encumbered by history. Go off and do something wonderful. And I think this is a great point for Haystack, because Haystack's history have so far been nothing but positive. And we should not just sit around thinking, oh yeah, well, we've done great. But think about what is the next thing, how we could expand, how we could, as a community, grow together and bring some new elements and be ahead of the game. Vigo made me put this. Thank you.